Okay, today we are going to discuss power series. Okay, but we know about when the series is converges, and we know some test. Comparison test, ratio test. Okay, power series. So already we know that what is series. So series is nothing but is of the form summation an, where n equal to 1 to infinity, where an is a real number. Okay, and we know that when this series is convergent, there are some tests. You can use the ratio test or comparison test or Cauchy n through test. There are so many tests to check the series is converges or not. Okay, we know about convergence and divergence of this series. So power series is of the form. So just is of the form summation an into x power n, where x is unknown, where n equal to 1 to infinity. Now the question is, for what values of x the series is converges? Okay, so this general form is called power series. A series is of the form, a series of the form summation n equal to 1 to infinity a n x power n. Okay, so is known to be a real infinite series. This is of the form is called as called a real infinite series, infinite power series. Power series where these a-n's are real numbers, where this a1 a0 even take summation 0 to infinity is not a measure. So these a-n's are real, and this x is unknown. This x is a real variable. Real variable. Now, more general form of the power series about the point x naught is of the form summation an x minus x naught power n, where n equal to 0 to infinity. So this is general form of power series about the point x naught. If you take x naught equal to 0, you'll get the this format. Okay, maybe we call this equation number 1. So more generally, so here I have to use one equation number 1. So because we can convert this into this, okay, we can substitute y equal to x minus x naught, you will get a of the form y power n. Okay, so now for we are going to discuss for what values of x the series 1 is converges, for what values of x the series is diverges. So that number is called radius of convergence. Okay, so there are some important fact about the series. The first fact that sometimes the series converges. Suppose if substitute for x equal to 0, if substitute x equal to 0, then what you will get? The series itself is 0, because 0 into anything 0. So therefore, the series is converges. Therefore, if you take any series, is converges at the point x equal to 0. Okay, so every power series, if you take any power series, is converges. Converges for x equal to 0. Because if substitute x equal to 0, we get the C sum itself 0. Therefore, automatically 0 series is converges. Okay, this is the first fact. And suppose the series is not converges other than this x equal to 0, then we call this is nowhere convergent. Okay, so however, okay, otherwise, if suppose if the power series is not convergent for all x except 0, if a power series converges for no value, for no value other than 0, other than x equal to 0, we say that the given power series nowhere convergent. The given power series is nowhere convergent. Okay, nowhere convergent. So second fact that suppose a series is converges for all values of x in the given domain, then such a series is called everywhere convergent. Okay, so if a given series, a given power series converges for all x, converges for all values of x, we say that the given power series is, we say that the given power series is everywhere convergent. Everywhere convergent series. Okay. Okay, such a series exists. What is an example? Okay, so what is an example for the first one? So example for the first one, if we take summation n power n into x power n. Okay. So if substitute x equal to 0 is always 0 series, therefore it always converges. If it takes any other value other than 0, then this series is not convergent. Okay. Now for this example, is converges any point, that is summation x power n by n factorial. So here an is 1 by n factorial. So this series is always convergent. Actually, this is nothing but e power x. Okay. So actually, this is nothing but e power x formula. 1 plus 1 x by 1 factorial plus x square by 2 factorial, etc. x power n by n factorial and so on. This is nothing but e power x. This converges, the sum is e power x. This e power x converges all points. Okay. But this series is not convergent. Okay. But is convergent only at x equal to 0. Now, the third fact that suppose the series is converges some point and diverges some other point. Okay. So third fact that if the given power series converges for some values of x, if the given power series converges for some values of x and diverges for other values of x, then the set of all values of x for which the series is convergence, we call that region is region of convergence. Then the set of all values of x, set of all values of x for which it is convergent is known as its region of convergence. Region of convergence. Okay, for example, if we take this, if we consider this power series, example, suppose summation x by r power n, that is x power n by r power n, summation n equal to 1 to infinity or 0 to infinity. Now, this series converges, and we know that the an is here. If you look at general case, so we can look at this is an. Now we know that an power 1 by n is nothing but just x by r, and we know that this is less than 1 modulus of this. So this is less than 1, then this is converges. This is greater than 1, this is diverges. Therefore, less than 1 means what? Mod x is less than modulus of r. Okay, modulus of, if you take r is a positive number, therefore this is less than r. Therefore, this series is converges for mod x is less than r and diverges for mod x is greater than 1. Sorry, greater than r. And what about for x equal to r? If substitute x equal to r, you'll get to 1. This again diverges because 1 plus 1 plus 1 is diverges. Okay. So therefore, this series is converges if the mod x is less than r, diverges if mod x is greater than or equal to r. Because if you take x equal to r, we'll get this r and r are cancelled, we get 1 is nothing but 1 plus 1 plus 1. That series is diverges. Therefore, for x equal to r also diverges. Now, this region mod x equal to r is nothing but this interval minus r strictly less than x strictly less than r. That is the open interval minus r comma r. So this is called a region of convergence. Region of convergence of this series. Okay. Now we define what is the radius of convergence of the series. Okay. So the given series does not converges everywhere or nowhere. That means what? It converges some point, diverges some other points. Then we define the radius of convergence. Definition. So if a given power series does not converge everywhere, or nowhere, then a definite number, then a definite positive number, actually, a positive real number, positive number r, we can define positive number r exists such that the given power series converges for all x less than r and diverges for a mod x greater than r. Okay, such that the given power series converges for all mod x is less than r. For all x, it's a mod x less than r is converges and diverges for all x mod x is greater than r. It diverges. Such a number r is called the radius of convergence. Okay, such a number r is known as radius of convergence. Is known as radius of convergence. And the interval open interval minus r to plus r. This open interval is called interval of convergence. Okay, the interval this is called the interval of convergence of the given power series. Okay. Okay, we will discuss some theorem, and there is a formula for finding the radius of convergence. Okay, theorem. Suppose we have a power series with all ANs are non-zero. If summation AN x power n okay, so n is equal to 1 to infinity, I don't write these things, okay, is such that, okay, be a series, okay, power series such that all the ANs are non-zero. If all the ANs are non-zero for all n, and we define 1 by r equal to limit n goes to infinity an plus modulus of an plus 1 by an. N plus 1th term by nth term modulus, and then take the limit. The value is 1 by r, then r is the radius of convergence. Then the series summation an x power n is convergent for all x less than r. For mod x is less than r, and diverges for mod x is greater than r. So this is a one theorem to find the radius of convergence, provided all the ANs are non-zero. Okay. One more theorem. So if we have to check for x equal to r, for what happened for x equal to r, you have to substitute x equal to r in the given series, and then you have to check the series is convergence or not. If it is convergence, then you have to include that r in that condition less than or equal to. Suppose if substitute x equal to r in the given series diverges, then you have to put greater than or equal to here. Okay, depending upon the series converges or not for the point x equal to r. Okay. Now the next theorem. So again, we have a series with all the ANs are non-zero. If summation an x power n such that is a series such that all the ANs are non-zero for all n, and we define 1 by r equal to, and 1 by r equal to limit n goes to infinity modulus of an power 1 by n, then the series is converges, then summation an x power n is convergent for mod x is less than r. Convergent for mod x is less than r, and diverges for mod x is greater than r. And then you have to check for x equal to r. Okay. This is another theorem. Now both will get the same answer. Anyway, now there is important theorem that is called Adam's theorem. A Cauchy-Adams formula, sometimes called Cauchy-Adams theorem. The same thing. So what the theorem is called? Cauchy-Adams theorem. So the radius of convergence of the power series is r, where r equal to 1 by limit. So the radius of convergence of the power series summation an x power n is R, where R is nothing but 1 by limit modulus of an power 1 by n. Okay, this formula is called Cauchy-Adamant formula. Okay. Okay, now we solve some problem to find the radius of convergence of the following series. Exercise. Look at the series x by 2 plus 1 into 3 by 2 into 5 x square plus 1 into 3 into 5 by 2 into 5 into 8 into x cube and so on. Now find the radius of convergence of this series. First you got to write the nth term of this series. Okay, solution. Now what is an? Actually the first term is here 1 into x, right? So therefore the numerator is a multiple of odd numbers. Therefore 1 into 3 into 5 into etc. The nth odd number is 2n minus 1. The denominator 2 and then 2 plus 5. That means you are adding 3 and you are adding 3 here. So therefore otherwise is nothing but is of the form 3n minus 1. If you substitute n equal to 1, you will get 2. If you substitute n equal to 2, you get 6 minus 1 is 5. Therefore 2 into 5 into 8 into etc. 3n minus 1. You know how to find this nth term. Okay. So this is our an. Therefore the given series is of the form summation an x power n, where an equal to this. Now you have to find an plus 1 by an, or you take the reverse. Okay, then what will happen? So if you take 1 by r, then we have to take an plus 1 by an. Suppose you are writing r means what? You take an by an plus 1. So what is the radius of convergence? R equal to limit n goes to infinity modulus of an by an plus 1. So otherwise, if you want to take this original formula, then take 1 by r. Therefore, 1 by r equal to limit n goes to infinity modulus of an plus 1 by an. Since all the ans are positive, therefore you have to no need to write this modulus. Therefore, this is equal to limit n goes to infinity an plus 1. That is, substitute n equal to n plus 1, we get 1 into 3 into 5, etc. 2n plus 2, therefore we get 2n plus 1 divided by, again here substitute n equal to n plus 1, 2 into 5 into etc. 3n plus 3, we get plus 2 into an, therefore into 2 into 5 into 8 etc. 3n minus 1 by 1 into 3 into 5 etc. 2n minus 1. Okay, therefore the previous atom here 2n minus 1. Okay, in this product. Again the previous term is you have to subtract 3, therefore we get 3n minus 1 here. Okay, so we can cancel this term and then the first 3n minus 1 term. Again we can cancel this and this term. Therefore what we'll get in the numerator we have 2n plus 1. The denominator we have, so limit n goes to infinity 2n plus 1 divided by 3n plus 2. You can take n outside and then cancel as n goes to infinity. Therefore, this is nothing but limit n goes to infinity. If we take n outside and then cancel, we have 2 plus 1 by n, the numerator. The denominator, we can take n outside, therefore 3 plus 2 by n. As n goes to infinity, this goes to 0. Again, this goes to 0. Therefore, we get 2 by 3. This is equal to 2 by 3. This is 1 by r. But what is r? Therefore, r equal to 3 by 2. Now we find the radius of convergence r. R equal to 3 by 2. Therefore, the series is convergence for all x. Therefore, it is the given series is it is converges for mod x is less than 3 by 2 and diverges for mod x is greater than 3 by 2. Now we have to check, but in the question they ask only the radius of convergence. The radius of convergence is 3 by 2. So then you have to substitute x equal to 3 by 2 in the given series. You have to check the given series is converges or not. Anyway, this is a radius of convergence. And the interval of convergence is minus 3 by 2, open interval minus 3 by 2, comma, plus 3 by 2. This is the interval of convergence. Okay. Now we solve one more problem. Find the radius of convergence and exact interval of convergence. Consider this series summation n plus 1 by n plus 2 into n plus 3 into x power n. Okay. So here what is our an? An is this. So an equal to n plus 1 by n plus 2 into n plus 3. Since all the ans are non-zero, therefore we can find what is an plus 1 by an and then take the limit. So this is nothing but n plus 2 by n plus 3 into n plus 4, that is an plus 1 into an. Therefore this is nothing but n plus 2 into n plus 3 by n plus 1. This is because by an means you have to reverse it. Now we can cancel n plus 3, n plus 3. In the denominator, n plus 2 whole square, you can take n outside, therefore we get n square. Therefore we get 1 plus 2 by n whole square. The denominator also we can take n outside from both sides, therefore we get n square. Therefore in the first term we have 1 plus 4 by n. From the second term, if we take n outside, we get 1 plus 1 by n. Now we can cancel n square. Now if we take limit n goes to infinity, modulus, okay, no need to write because everything is positive anyway. So what is the value? As n goes to infinity, this 2 by n goes to 0, therefore the numerator is 1, denominator also 1, therefore this 1. So this is nothing but 1 by r. 1 by r equal to this, therefore r equal to 1. Therefore we get the radius of convergence is r, therefore the series is converges. It is converges for x mod x is strictly less than 1 and diverges greater than 1 and diverges for mod x is greater than 1. Then what happened? Mod x equal to 1. That is a question. Therefore, there are two possible for x, right? Either x equal to plus 1 or x equal to minus 1. Now, if you take x equal to 1, what happened for the case x equal to 1? Now, substitute x equal to 1, the given series, then this is cancelled. Okay. So, therefore, we get a new series that is summation n plus 1 by n plus 2 into n plus 3. So, that is an equal to this. You can take n outside and then cancel. We have a numerator 1 plus 1 by n. The denominator you can take n outside. We have 1 n is there. Therefore, 1 plus 2 by n and 1 plus 3 by n. Right? So, this is an. Now, choose bn equal to 1 by n and then find the limit an by bn. So, again, this n and this n cancel. If you take limit n goes to infinity, you will get 1. It's non-zero number. So by known theorem that both an and bn have same behavior, since summation Bn is divergence because it's 1 by n series. Therefore, summation An is diverges. Therefore, this series is diverges. Therefore, for x equal to 1, the series is diverges. Now, what happens if x equal to minus 1? For the case x equal to minus 1, substitute this value, summation, the given series becomes summation n plus 1 by n plus 2 into n plus 3 into minus 1 power n, because x value is minus 1. Now, this is alternating series, and we know the theorem by Leibniz formula that when this alternating series converges, that un should be decreasing, that is un plus 1 less than or equal to un, where this is our un. So, what is our un? Un equal to n plus 1 by n plus 2 into n plus 3. So, the Leibniz theorem says if everything is decreasing and everything is positive and this converges to 0, then the alternating series is converges. Okay, clearly these uns are positive. And we know that if n goes to infinity, this is 1 by n, because we can write un is n plus 1. You can take n outside and then cancel. So we get simply 1 plus 1 by n, the numerator. The denominator n into 1 plus 2 by n, 1 plus 3 by n. As n goes to infinity, this goes to 0. Therefore, this un satisfies the third condition. Second condition also satisfied because everything is positive. Only thing you have to check that this is decreasing. So just to find un plus 1 by un. Otherwise, un plus 1 minus un, we have to prove this is less than 0. So anyway, I leave to the exercise. So just you got to check. So this satisfies decreasing. So this is decreasing. By Leibniz formula, this alternating series is converges. Therefore, the series is converges for x equal to minus 1. Therefore, what is the interval of convergence? So, radius of convergence is r. Okay. Therefore, minus r, open interval minus r comma r is the interval of convergence. That is nothing but minus 1 comma plus 1, open interval. But here, minus 1 is we have to include. That is closed interval minus 1 comma 1, because minus 1 is also, if x equal to minus 1, the series is converges. Therefore, the interval of convergence is closed interval minus 1 comma open interval 1. Therefore, the interval of convergence, the interval of convergence is closed interval minus 1 comma open 1. Okay, so you have to check that point. So for x equal to 1 is diverges, but x equal to minus 1, it is converges by Leibniz alternating series. Okay. Okay. Now we got some more theorem, very important theorem about the absolute convergence. So we know that when we say a series,
Sir, why we have to check that point, sir?
because by the theorem says modulus of x is greater than r is diverges, less than r is diverges. But the theorems not say about what happened for x equal to mod x equal to r. Okay. The theorem says only for the points mod x is less than r is converges, mod x is greater than r is diverges. Then what about mod x equal to r? We have to check that point also. Okay, we have to check for all points the series converges or not. The theorem says for mod x is less than r. So mod x less than r means what? So this is a real line. So this is my open
Sir,
interval plus.
equal to r. R is the radius of convergence, no, sir.
Yeah, that is
By the
radius of
definition,
convergence.
that is the point where it will converge. The
No,
series
no, no,
converges, no, sir.
no, no, no. That is radius. We can center is suppose the origin. So maximum radius is r, but we don't know about the endpoints. Radius is r.
Okay.
Okay. Then we have to check the endpoints also. Both the endpoints minus r and plus r, if it is converges, then you can include there is closed interval minus r comma plus r is the interval of convergence. Suppose sometimes this boundary points is converges, but at the point this interval, this endpoint, the series is not converges sometimes. Okay, but radius is okay, because why I'm saying radius? If you take circle, circle there are two types of circle, right? Open disk or disk. So boundary is included, then we say again is radius is r. Suppose if you consider a circle with radius r, we say that r is a radius. Suppose if you take open disk, that is the boundary point is not included, even we can call the r radius is r. Okay. So radius r means not mentioned that that boundary is included. It's not a matter, but radius is r. Okay.
Okay.
So we have to check that endpoints. What happened for mod x equal to r. Now, and we know that in the series part we studied about absolute convergence. So, but when we say a series absolute convergence, modulus of an is convergence. So, if the given series summation modulus of an is converges, then we say summation an is absolute convergence. Okay. So we know that when we say a series absolute convergence, if we take the modulus of the numbers, if the series is converges, then we say it's absolute convergence. Okay. Well, actually, we say you have to write here. Okay. So we say the series is absolute convergence if summation modulus of an is converges. Now, similarly here, when the power series is absolute convergence, for what points the series is absolute convergence? Once you know the radius of convergence, when the for what points the series is absolute convergence? That is very important theorem. So says, suppose if the power series summation an x power n converges at some point, okay, converges for some point x equal to x naught, then it is absolutely convergence. It is absolutely convergence. Convergent for point x equal to, for every point x equal to x1. But what is the relation between the x1 and x0? Modulus of x1 is less than, strictly less than modulus of x0. Okay. So if you know the series converges at some point x0, then the series is absolutely convergent for all x1, which is less than mod x0. Okay. It's very important here. And it diverges, suppose another theorem. Okay. So it's very important theorem. If you know convergence at one point x0, then if you take any point x1 which is less than x0, is always absolute convergence. Okay. So next theorem for divergence. Suppose the series is divergence for some point x0. Suppose the series summation an x power n is diverges. Diverges for the point some x equal to some x0. Then it is diverges for every point bigger than this x0. Okay. Then it is diverges for every. This is like comparison test. Okay. So in the comparison test, we know that if an less than or equal to bn for all n, if this series converges, then this series converges. Any smaller than. Suppose this is diverges, then this diverges. Okay. Same thing here. If you know one point, the series converges for one point, then it's the absolute convergence for all points less than that point. If it is diverges, then any point bigger than that. So it is diverges for every x equal to x1, where this modulus of x1 is bigger than modulus of x0. For all points bigger than this x0, is the series is diverges. Okay, is very important thing. So another important theorem is you have to merge these two. Suppose the series is absolutely convergence for all points within this interval of convergence. Once you know the interval of convergence, open interval minus r comma plus r, then the series is absolutely convergence within that interval. So next theorem. a power series is absolutely convergence within its interval of convergence and it diverges outside the interval. A power series is absolutely convergent within its radius of convergence, interval of convergence, and diverges outside it, and the series is diverges outside the interval. Outside it. Okay. So absolutely convergence happen only within this interval of convergence, minus r to plus r. That should be strictly less than r, not exactly. Sometimes, if you take, sometimes the interval of convergence sometimes closed r comma plus r, open r. Okay. So one side is open, one side closed. Suppose interval of convergence then, but the series absolute convergence only for strictly less than. Suppose if you take this is minus r and this is r, then absolute convergence happen only within this interval, not in the endpoints. Okay, that is very important thing. Okay, another theorem. Suppose we define the function f of x equal to summation a in x power n, then this is uniformly converges for any thing. Simply saying otherwise, the derivative of the function. So otherwise we can simply say okay, suppose we define the function f of x equal to summation a n x power n. For what? For values, for each values of x, we define f of x equal to this. Now, if you know this radius of convergence, this series, then what is f dash? We can define term by term differentiation is nothing but summation a n is constant. Therefore, n into a n power x power n minus 1. Now, what is the radius of convergence of this? So both have same radius of convergence. Suppose the radius of convergence of the power series is this, then the derivative, this series also the same radius of convergence. Okay, and even if you take integration, what is the integration of this? Integration of f of x nothing but summation a n x power n plus 1 by n plus 1 have the same radius of convergence. So that is a theorem. So provided this f should be continuous and then differentiable in the interval minus r comma r, because this is the radius of convergence. Within this interval, this f is differentiable and f is continuous. Okay. Now, what the theorem says, the series obtained by integrating and differentiating by the power series term by term, the series obtained from the original power series by integrating and differentiation by term and differentiating power series by term by term as the same radius of convergence by the given original series. The same radius of convergence. As the original series. It's very important here. So if you know the radius of convergence of this series, then if you take the derivative by term, this series also radius of convergence r. And if you take the integration, what you'll get summation a n x power n plus 1 by n plus 1. This series also radius of convergence r. Okay, therefore this theorem is very important. Now there are some Abel's theorem is there. We can state the Abel's theorem. That is called the first form of Abel's theorem. First form of Abel's theorem. Okay, what is this says? Suppose we have a power series converges at the end point of the interval. Okay, in the minus r comma r is the interval of convergence. Suppose if the power series summation a in x power n converges at the end points. At the end point x equal to r of the interval of convergence, what is the interval of convergence? Suppose this converges, therefore okay, then open minus r, closed r, because it is converges at the one endpoint x equal to r. Then the theorem says it is uniformly continuous. It is uniformly convergence. It is uniformly converges, uniformly convergent in the closed interval 0 to r. In the closed interval 0 to r. So it is uniformly convergent in the closed interval 0 to r. But the general theorem says within that interval it is uniformly convergent. But Abel's proved that if suppose this converges at one endpoint x equal to r, then it is uniformly convergent in the closed interval 0 to r. This is the first form of this. Suppose is converges the left endpoints x equal to minus r are both the endpoints. In this case, the series is uniformly converges to minus r, closed interval minus r comma 0, or the entire interval. Okay, if it is converges in the left endpoints, the right endpoints, this is uniformly convergence. Suppose converges at x equal to minus r, then it is uniformly converges on the interval close 0 to minus r to plus r. Suppose it is convergence both the endpoints minus r and plus r, then it is uniformly convergence on this interval this. Okay, if provided the series converges at both the endpoints. Okay, because already you know that is continuous on the closed interval a comma b, it is uniformly continuous. Same thing here. Okay. Now, what is the second form of Abel's theorem? Next theorem, the second form. Second form of Abel's theorem. Suppose we have a power series with the radius of convergence r. If we define f of x equal to the series of summation a in x power n, then if you substitute x equal to r, so if the power series, okay, if summation a n x power n has a radius of convergence, summation a n x power n, where n equal to 0 to infinity, be a power series with the radius of convergence is r, power series with the finite number r, with the finite radius of convergence. Finite radius of convergence we call R, and let f of x equal to summation a in x power n equal to 0 to infinity. Okay, where this R is this x lies between this interval. This f defined only on this interval, not the entire real number. So f defined on only this bounded interval, open interval minus R2 plus R. Okay, then suppose if the series summation an r power n, if substitute x equal to r, suppose if this series is converges, then limit x goes to r minus the right and left hand limit, x goes to r minus f of x is nothing but summation an r power n, where n equal to 0 to infinity or anything. Okay, the limit x goes to r minus f of x is nothing but the series, because the series is converges, therefore it has some value, that is a value, that is the limit of the function f of x from the left hand limit. Okay, so the particular case, if you take r equal to 1, maybe I can state as a the above, we have to modify the above theorem, that suppose let f be the let f of x, sorry, let an x power n be the series with the radius of convergence 1, with the radius of convergence is 1, that is r equal to 1, and let define f of x equal to the series summation a n x power n in the interval minus 1 less strictly less than x less than 1, then if the series, if substitute x equal to 1, then what will happen? If substitute x equal to 1, then if the series just summation an is converges, because substitute x equal to 1, we get this one. If converges, then limit x goes to 1 minus f of x is nothing but just a summation an. Okay. Now, what is the corollary of this one? If you take the corollary, suppose if the series summation minus 1 power n an converges, then limit x goes to 1 minus f of x is summation just this term minus 1 power n an, where f of x nothing but summation an x power n. Okay. Now, already we know that the Abel's theorem, the product of two series is converges only when one is absolutely converges. All the things we already studied. Okay, so almost we covered the radius of convergence. Okay, maybe I solve some one problem and then we stop now. One problem from this radius of convergence is asked in the JAM exam. Okay, so find the set of all values of x for which the series is converges. The set of all x at which the power series summation n equal to 1 to infinity n by 2n plus 1 whole square into x minus 2 power 3n converges. Yes. So for what values of x the series is converges? For set our fine. So first option close to 1 minus 1 comma open 1. Second option close to minus 1 close to 1. Third option 1 close to 1 open 3, and the fourth one is close to 1 close to 3. Okay, first we have to take all this should be an, and then you have to find that when the series is convergence. Okay, and then you have to find actually you have to find the radius of convergence. So first you take an is entire thing. Okay, n by 2n plus 1 whole square into x minus 2 power 3n. Now just to find an plus 1 by an. So this is nothing but an plus 1 is nothing but n plus 1 into x minus 2 power 3n plus 3 by 2n, that is 2n plus 2 1 3, 2n plus 3 whole square, that is an plus 1 into an, therefore n into x minus 2 power 3n into the denominator is n plus 1 whole square. Now we can cancel something. So we can cancel x minus 2 power 3n. Okay, and this so we can take n outside from the first term. We get n into 1 plus 1 by n, and we cancel x minus 2 power 3n. Therefore remaining is x minus 2 power 3n. Sorry, 3, just 3. And the last term we can take 2n outside or n outside. So if we take n outside, there will we get n square. Therefore we get 2 plus 1 by n whole square. In the denominator, again you take n outside from these, we get n square 2 plus 3 by n whole square, and we have n, and this term we cancel. Now we can cancel this n, and we can cancel this n square. Now finally we get something. Now as n goes to infinity, then what will happen? Limit n goes to infinity modulus of an plus 1 by an. So I missed the modulus, so you have to put modulus. So as n goes to infinity, this goes to 1 and this goes to 2, right? And this goes to 2, sorry, 4, because 2 square is 4, and this also 4. 4 cancel, and there is some constant term. This is actually constant. Therefore we get this nothing but x minus 2 power 3. Okay, modulus of x minus 2 whole cube. And we know that when this series is convergence, if this is less than 1. Okay, if this is less than 1 is converges, greater than 1 is diverges. So now this converges for that mod x minus 2 cube is less than 1, and diverges for mod x minus 2 whole cube greater than 1. Now we have to simplify this. So this is nothing but, so since x minus whole cube is less than 1, therefore x minus 2 also less than 1. Okay, cube is less than 1, therefore should be less than 1. So this is nothing but minus 1 less than x minus 2 or less than 1. You can add 2, we'll get 1 less than x less than 3. Therefore, now we get the interval of convergence is open interval 1, 3. Okay, this is the interval of convergence now. So for all points x lies between this interval, the series is convergence. Now we have to check for endpoints. If substitute x equal to 1, substitute x equal to 1 in the given series, substitute x equal to 1, what you will get? So substitute x equal to 1, 1 minus 2 is nothing but minus 1. So minus 1 power 3n is nothing but minus power n. So therefore we get an alternating series. So therefore the series become alternating series. Okay, so if substitute x equal to 1, you will get what is that, n by 2n plus 1 whole square into minus 1 power n. So is converges or not? This is alternating series. What is our un? Un is n by 2n plus 1 whole square. You can easily check that as n goes to infinity, un goes to 0. And uns are positive. Satisfy second condition. Next thing is you have to check that is a decreasing sequence. So this un satisfy these three conditions. Therefore, this is converges. By alternating series, this is converges. So therefore, for x equal to 1, this series converges. Therefore, now we got to include this x equal to 1. Now substitute x equal to 3, then the series become 3 minus 2, that is 1. Therefore, we get n by n plus 1, sorry, 2n plus 1 whole square, right? Substitute x equal to 3, we get this. Now we have to check the series converges or not. So what is our an? An equal to, if we take n outside and then cancel, we get 1 by n into 2 plus 1 by n whole square. Now choose bn equal to 1 by n. Now what is an by bn? Is cancel, this n cancel, we get 1 by 2 plus 1 by n whole square. The limit, this converges to 1 by 2, there is a non-zero number. Therefore, both an and bn have the same behavior. Since bn is diverges, therefore an is diverges. Therefore, at the point x equal to 3, this is diverges. Therefore, it converges only close interval 1, open 3. Look at the third option. So third one is correct. Okay. So that is the idea. Okay, we can stop now. We will discuss in the next class.